Hello everyone, this is Y. Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. So in this session, uh, we are going to discuss about the relational database design or model in DBMS. Relational database design or relational database model in database management system. So we already discussed in the previous sessions. We can have different types of models to design the databases. So ER model, a relational model, network security model, different types of models we are having to design the database also. Hierarchical model. So in this session we are going to discuss about the designing of relational model. So the relational database design or model was introduced by C.F. Cord in 1970 actually, and it is the most widely used data model. So among all the data models, relational database model is very widely used model because the relational model can have the relations between two tables or any tables between any of the database objects also. So that's why the relational database model is indirectly it's popular, and the relational database model describes as a collection of interrelated relations. That means the tables can have interrelations. So all the attributes from one table is indirectly related with all the attributes of another table. So like example, customers and order table, student and college table. So like the way different types of attributes from the database tables, they can have the interrelated to each other. So a relational data model involves the use of data tables that collect groups of elements into relations. The primary key is a fundamental tool in creating and using relational database models. So to maintain that interrelation of the tables in the database, the primary key is a fundamental tool. So it tells that the relationship is in between the two tables. So what are the main objectives to design this relational database model? So first one is what? Eliminate data redundancy. So that means when we are having different types of values to inserting into the tables, we may have different data duplicates. So to reduce the data, we are going to design this one. The same piece of data shall not be stored in more than one place. That means the place can have the same data items is not a good way. So the data is to be different and the place is to be different. This is because duplicate data not only waste storage spaces but also easily leads to inconsistencies. So entering the duplicate values is not only wasting the storage, and also it leads to inconsistency of the data. So the main objective of designing this relational database model is eliminate data redundancy, ensure data integrity and accuracy. So it is the maintenance of and the assurance of and the accuracy and consistency of data over its entire life cycle, and it is a critical aspect to the design and implementation and usage of any system which stores, the processes or retrieves the data. So the maintenance of so we have to give the assurance of the data, and we have to maintain the consistency of the data, entire overall the life cycle of the particular application. So we have to maintain that integrity. For this purpose also we are going to use this relational database model. So ensure data integrity and accuracy. So to maintain the data, eliminate data redundancy and maintain data integrity and accuracy. For these are the objectives to design relational data model. The relational model has provided the basis for research on the theory of data or relationship or constraints. So research on theory of data or relationship or constraints. The second one is numerous database design methodologies. So all these point of aspects, the relational model is going to be used. The standard database access language called structured query language (SQL) So in these applications also we are using, and almost all modern commercial database management system, almost all modern commercial database management systems also, we are going to use this relational model. So the two tables below related to each other through the product code field. So here in this diagram we can have two tables. One is table 1 and second one is table 2. So these two tables are related to each other with the help of product code. So indirectly product code having primary key, because the primary key is a tool to interrelate the two tables, so that here product code have the primary key and this product code is combining these two tables. So these are the relational model basis, and the four stages of relational data model, which are as follows. The four models. So what are the different stages are available, different stages are passing to design this relational model. First one is what? Relations and attributes. So attributes are nothing but it shows the behavior of any object. And the relations are nothing but a logical connection between two entities. Two entities are two attributes. So relations and attributes. The various tables and attributes related to each table are identified. The tables represents entities and the attributes represent the properties of respective entities. So here the table names are representing entities and the attributes representing properties of their respective tables or respective entities. Next one, primary keys. So the attribute or set of attributes that help in uniquely identifying a record is identified and assigned as the primary key. So the primary key as a tool for interacting those two tables and the relationships. So relationship between the various tables are established with the help of foreign keys. So some of the tables are interrelated with the foreign keys, and the foreign keys are attributes occurring in a table that are primary keys of another table. So the one key is related with another table key. That key is said to be a foreign key. So the type of relationships that can exist between the relations are one-to-one relationship, or one-to-many relationship, and many-to-many relationship. Next one, normalization. So this is the process of optimizing the database structure. That means reducing the database structure. So we are going to use a model to reduce the database structure, reduce the complexity of the database also. So normalization simplifies the database design to avoid redundancy and confusion. That means redundancy is nothing but eliminates eliminating data duplicates and consistency also. The different normal forms are as follows. The first one is first normal form, second normal form, third normal form, fourth, that means BCNF boycott normal form, and the fifth normal form. So these are all the normal forms to eliminate the data duplications and maintaining the consistency of the data as per the process of normalization. So by applying a set of rules, a table is normalized into the above normal forms in a linearly progressive fashion. The efficiency of the database design gets better with each higher degree of normalization. So whenever the duplications are less, whenever the duplications of the degree is less, then automatically the data is going to be get effective. That means it maintains the efficiency of designing is better. So advantages of relational databases. So the main advantages of relational databases are they enable users to easily categorize and store data. So that means easily understand the users who are belongs to the category of particular data, and it stores all the database users. So advantages are, first one is accurate. So the data is stored just once, which eliminates the data duplications. That means only one time or only one data item is to be stored. And second one is flexible. So complex queries are easy for users to carry out. And collaborative. So multiple users can access the same database. Multiple users can access the same database. And the next, trusted. The relational database models are mature and well understood. So that we can say that it is a very trusted. And secure. So data in tables within a relational database management system can be limited to allow access by only particular users. So only particular users are nothing but authorized users. Only that particular authorized users who are having authentication to access the database, they are said to be, they are only having the permission to access the database, or permissions to do some things on database to allow them. And the next, pitfalls in relational database design. So pitfalls are nothing but some design issues in relational database design. So relational database design requires that we find a good collection of relational schemas. So whenever you design a database is to be good, it should reflect the efficiency of the database to use the applications. But a bad design may lead to repetition of information, inability to represent certain information. So duplications are allowed, and repetitions of information leads to, it represents inability to represent certain information. And the design goals for relational database. Design goals. So what are we achieving by designing this relational database design? So first one, avoid redundant data. And second one, ensure that relationship among attributes are represented. And facilitate the checking of updates for violation of the database integrity constraints. So facilitate that checking of updates. Every time we have to check the updates for violation of database integration constraints. So these are all the design goals for relational database. So we can have the design issues. One is redundancy and the second one is null values. So consider that relational schema. So branch name, branch city, assets, customer name, loan number, amount. These are all some attributes from the table. But redundancy, while we're talking about redundancy for this table, data for branch name, branch city, assets are repeated for each loan that a branch makes a waste space and complicates updating. So the redundancy leads to wastage of the space as well as it complicates updating also. And the second one, null values. So null values cannot store information about a branch if no loan exists. So they can use null values also. So by providing null value on the particular item, so it indirectly wastes some space for the particular user. But they are difficult to handle. In the given example, the database design is faulty, which makes the above pitfalls in database. So we observe that in a relational database design, if the design is not good, then there will be faults in the database. So definitely we can say that if design of the database is not good, so the database leads to redundancy and inconsistency. But whenever the database design is good, then we can say that a database maintains consistency and the database maintains not redundancy. Also. And the next one is relational decomposition. So decompose is nothing but it is a process of dividing a table into two parts or two tables. So if any table can have the complex structure, then we can easily decompose it into two ways. So when a relation in the relational model is not in appropriate normal form, then the decomposition of a relation is occurred or required. So if any table or any model is not in the normal form, so that we can apply this concept, decomposition concept is applied. So in a database, it breaks the table into multiple tables. So decomposition is nothing but it is a process of decomposing or dividing the table into multiple tables. So if the relation has no proper decomposition, no proper decomposition, then it may lead to problems like loss of information. So if you are not doing proper decomposition, then your data is going to be lost. So decomposition is used to eliminate some of the problems of bad design like anomalies, inconsistency and redundancy. So these are some bad design anomalies like inconsistencies, anomalies and redundancy. So types of decomposition. So decomposition, one is lossless decomposition and the second one is dependency preserving. Second one is dependency preserving. So decomposition is nothing but the table is divided into multiple tables. Why we are dividing means to avoid these problems like bad design like anomalies, inconsistencies and the redundancy of the data. So to avoid that, avoiding all these things, we have to decompose the tables. So first one is lossless decomposition. So lossless decomposition is nothing but if the information is not lost from the relation that is decomposed, then the decomposition will be lossless. That means whenever you are decomposing the table into two tables, even you are doing that all the two tables decomposition, but you are not losing any data, then it is said to be lossless decomposition. Then it is said to be the decomposition will be lossless or lossless decomposition. So the lossless decomposition guarantees that the join of the relations will result in the same relation as it was decomposed. So by performing join operations of those two tables, we will get all the values from the previous table. We'll get the values from the previous table. So the relation is said to be lossless decomposition if natural joins of all the decomposition gives the original relation. So if we are doing the natural join operation on those two tables, we acquired that the original table values. So consider this employee underscore department table. This is one table which can have duplications, which can have the different values. So here the employee underscore department table contains employee ID, employee name, employee age, employee city, department ID, department name, and they can have the values also. So here the employee ID and the department table. So here the department table, department name is depending on department ID and as well as employee ID. Department ID and employee ID. So that the table is going to be decomposed because this is a complex structure of the data and we can decomposing this table into two parts. So the decomposed tables looks like this. The above relation is decomposed into two relations, employee and department. So employee table contains employee ID, employee name, employee age and employee city. But the department table, in the department table, the department ID is also depending upon employee ID, so that you can have the attributes like department ID and employee ID and the department name also. So we done the decomposition of the tables into two relations like employee and department. So now when these two relations are joined on the common column employee ID, then the resultant relations will look like. So employee join employee, natural join department, then we can have the same values from the previous table. What we are having the values from the previous table, what we are having the values from the previous table, that values we are getting after joining those two relations. After we are joining those two relations also, we got the same values from this table. So here, hence the decomposition is lossless join decomposition. So hence the this decomposition is lossless join decomposition. Next one is dependency preserving. So dependency preserving, it is an important constraint of the database. It is an important constraint of the database. In the dependency preservation, at least one decomposed table must satisfy every dependency. At least one decomposed table. That means we already decomposed a table. Employee underscore department table is decomposed into one is employee table, second one is department table, right? So at least one decomposed table, that means employee table or department table, any of those two table must satisfy every dependency of these columns. So department table columns or employee table columns, they can have a dependency on this employee underscore department table. So that is nothing but dependency preserving. So if a relation R is decomposed into relation R1 and R2 in the previous example, then the dependencies of R either must be a part of R1 or R2, or must be derivable from the combination of functional dependencies of R1 and R2. So that is nothing but a table 1 and table 2, relation 1 and relation 2, having that attributes are depending on the first table, depending on any of the attributes are depending on first table. So from previous example tables, we understood that R table values must be a part of either R1 and R2. So we said that what R table values, so this is the R, this R table values must be either R1 values or either R2 values. So you can say that it is a must be part of R1 and R2 for the R table. Hence they are functionally dependent on one to another table. Hence they are functionally dependent on one to another table. So that means the R1 and R2 values are at least depending on any of the values are depending on R table. So that it is said to be dependency preserving. Dependency preserving. So this is the concept of dependency preserving. So in this session what we discussed, so we already discussed about some relational database model. So what is the mean by relational data model actually, and what are the main design objectives of the database redundancy and integrity and constraints accuracy. So main design objectives and what is meant by relational database design actually. And the next, what are the relational model applications, that means where we are using this relational model in the real time actually, and how the relational tables, the relation is nothing but table, so how the tables are related to each other with the help of a common tool called primary key or foreign key, and what are the stages occur to design a relational data model, what are the different stages occur to design the relational database model, and what are the advantages of relational database, what are the different types of advantages. And the next, what are the pitfalls, that is nothing but design issues to design this database. So one is redundancy and the second one is null values, we already said that. So if anybody having any tables having dependencies values, then we can have to eliminate them. And the relational decomposition, so there are two types of relational decomposition, and why we are decomposing actually, we have to create a proper values, proper to design issues like bad design issues like anomalies, inconsistencies and redundancy. So to avoid that all the things, we are going to decompose the table. After decomposing the table, the decomposed tables can be joined together with the help of natural joins or inner joins, so that we cannot lose any information from the original table. We cannot lose any information from the original tables. So that is nothing but lossless decomposition. And last, dependency preserving also. Dependency preserving. So dependency preserving is nothing but what? We already said that any of the table values is depending on either R1 is R2 is depending on R, so that any of the attribute is depending on any other table, so that it is said to be dependency preserving. So this is about relational database design or model, different issues, different objectives, different uses and advantages, and decomposing values, decomposition techniques, types of decompositions. These are all we discussed in this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.